Thank you very much for your company. Welcome again to your channel Transmission Lines Engineering TV. Topographic survey with total station. Before starting this video, I want to extend my recognitions to those folks who make it possible the birth of the design of a transmission line. No. I'm not talking about us as the design engineers or the managers. I'm talking about those men and women who are capable of getting with their measurement equipment, radius, water, and Bowie knives to places like high mountains, jungles, plains, deserts, frozen zones, including areas that can put their own lives at risk. Can you guess who I'm talking about? I mean the brave topographers, those who are always sweating with dirty clothes, have their skin torn by the vegetations and burned by the sun, walking carrying on their backs an equipment as heavy as a total station, looking for trails to move forward with his Bowie knives and medication suitcases. Thanks to their work, there are not only transmission lines, there are trains, roads, pipelines, etc. To all these brave men and women, I dedicate this video work so it serves to the designers of the new generations to see these people not as a single or simple employee, but as a human being of great value. Throughout my career in this industry, I have lived with these people for a long period of time, and believe me that I have gone through unforgettable life experiences as professional ethics, mutual help, louds, and even survival to save the life of a fellow worker. To all of them, my most sincere gratitude, and if some of you knows any topographer, I will greatly appreciate sharing this video with them. A topographical survey of a transmission line with a total station, it's an admirable work of high precision and human endurance. In the case of lines with flat topography without vegetation, there is no major problem for the vision of the team to the chainman, but for projects with in mountainous areas with a very dense vegetations, all visibility is obstructed. So it is like it says in a song from the Spanish poet Antonio Machado in his poem Walker, There's No Road, and interpreted by the Spanish singer Juan Manuel Serrat in 1969. The trail of a transmission line does not exist. It must be built in the only way possible without affecting the environment, walking and opening the trail with Bowie knives in hand. The topographic survey of a trajectory of the line is the #1 tool to bring to life a project. So there's no topographical survey, there's no project, and the designer will be hands-tied. Previously, before the digital age, the topographical survey was done as a state-of-the-art work with a theodolite and a chainman. After the transit, other surveying equipment arrived, but among all, the most used one is the total station, which this video is all about. Now we have the equipment, but what points should we measure with this equipment? Another way to perform a topographic survey is through LiDAR, which is light and detection and ranging imaging. But that will be something for another video. Before proceeding to the explanation of the survey with the total station, we will first touch base with the basic nomenclature to identify the basic data of a transmission line. So it is as follows. We have the central line, deflection point or PI, we have the center tangent point, CTP. We have as well the right side profile and left side profile. We have as well the device height and the prism height. We have as well the sighted point, and with it the inclined length, inclined angle, the horizontal length, transversal length, and transverse angle. For a transmission line with enough kilometers, sometimes it is necessary more than one single crew, each one with its respective equipment. This equipment is composed by transport vehicles with reinforced cabin, preferably for safety of the crew. So in case of an accident, the entire vehicle will be destroyed, but at least the cabin keeps the crew safe. We have as well the total stations with its accessories, prisms, GPS, portable radios for communications between crews, and one more for long reach with communications to the main camps. Something important: cellular communications can be lost in some areas, so this is why I recommend communications through radios, since they work by radio frequencies and not by satellites. Wood stakes and paint. Thermometer for measuring the ambient temperature. This is a basic one. Notebook or notepad. First aid kit for medications for punching animals. In a line, there are animals which bite can lead even to death of a co-worker in less than a couple hours. So if he doesn't receive medical attention and is evacuating from the place to a hospital, in some projects, a transmission line of great complexity, helicopters are used and available to transfer equipment and materials, and sometimes to save the life of a partner who in turn might be a parent. As preparations for projects of great length, I usually ask to the surveyor contractor for the calibration certificates of its equipment. So it is to say, every total station, due to its normal use, tend to present a margin of error which it's accumulating over the time in the equipment, and therefore it must be recalibrated in order to guarantee the precision of the measurement data. So I strongly suggest to include within your survey services scope of work the supply of a copy of the updated certification of calibration, because if you work with an equipment which calibration has expired, you run the risk of having a considerable errors. So on the other hand, to the survey services providers who are watching this video, in order to avoid serious problems, I really recommend always keep your updated certificates as part of your assets and investments and maintenance of your equipment, since this cost should not be in no way charged to your client, because it is part of the normal operation of the surveying business. A survey with a total station will collect the data of the sighted points, SPs, in latitude and longitude coordinates and elevation, and then recalculate them into its equivalent to the coordinate systems of your preference. First, the survey will start from the location of the center of the exit A-frame of the substation, in case we have at this point. However, for new substation construction projects, this location is not always available, so the survey can start from the very first point closest to this substation, perfectly defined and fixed, which we can call it a pivot point. which will be assigned a kilometer of 0 plus 0. Subsequently, once the position of the exit or arrival frame has been defined, this connection path will be surveyed and the station equation will be established. So, before continuing, it is necessary to know the meaning of the term station equation. What is this all about? Each point sighted, or SP, in addition of having its coordinates in latitude, longitude, and elevation, has an equivalent of distance or chainage from the pivot point as a kilometer 0 plus 0 to the sighted point. Suppose 50 meters, so that it reads 0 plus 50. But once it is measured from the new frame of the substation to the pivot point, it turns out that there is, say, some 153.48 meters, in such a way that the real chainage from the SP is no longer 0 plus 0, but 0 plus 153.43 meters. But it turns out that the rest of the chainage was calculated based on an SP with a chainage of 0 plus 0. So recalculate every single point with this difference in chain is a headache and a huge risk of calculations. So in order to avoid this risk that can be corrected in the as-built stage, we will define a station equation in the pivot point as follows. Number 1, from the pivot point backwards towards the substation, this point will have a chainage of 0 plus 153.48 meters, and the frame of the substation will have the chainage of 0 plus 0. Now, number 2, from the pivot point forward, the pivot point will have a chainage of 0 plus 0 in such a way that the chainage of all those SPs will not be affected by this station equation. My recommendation, subject to the best opinion of each one, is to work with UTM coordinates instead of working with a chainage, because it requires a lot of skill and organization to organize the work, especially when for some reason during the construction of the line it is necessary to make alignment changes which will directly affect the chainage of all the SP's points, bringing the consequences of having transmission lines with multiple station equations, which at some point could lead to confusion. So from my own experience, it has been much better to, at least for me, to work with coordinates rather than with chainage. Sorry to expand on this issue, but I think it is important to spend some time and have this concept very clear for everyone. So now let's get going ahead. In those areas where a trail must be done or must be made by hand, it's not really necessary to be very wide, just enough to not obstructing the vision of the total station. 1 or 2 meters is usually sufficient, depending on the applicable regulations, if they exist. Now, which are the points, the SPs, to measure with our total stations? For the line designer, it is important to obtain data of all types of general and specific crossings, general obstacles, I mean fences, both mesh and stones, because we never know who will stand on top of these fences, having a dangerous approach to the cable lines, rivers, roads, lakes, channels, drainage, buildings, etc. The survey of these obstacles are not only on the center of the line, but on the entire width of the right-of-way. For those obstacles outside of the central axis of the line, it is necessary to know their horizontal distances, which means the offset, to take them into account in the location of the structures for horizontal and vertical clearances. Each obstacle type, I recommend having a code list to easily identify each sighted point SP with its respective description, coordinates, and also some kind of notes or observations or recommendations from the surveyor, which although they are not designers, in my experience, they have given me very good help. Now, in terms of specific obstacles, we have crossings with roads, rivers of great flow or importance or navigable, potentially flooding areas, to avoid the location of structures in these areas, or the design of special foundations, railways, superficial and underground pipelines, distribution and transmission lines. That is, the crossings which involve infrastructures in charge of third parties agencies which require a crossing permit. For this type of crossings, we will talk about them in a different video. Along the transmission line, in addition of surveying the obstacles, it is required to have reading points on the central line and on its projections to both sides of the line to a certain number of meters, or where the topography of the underground changes, as it can be in hills, slopes, etc. These points are called center tangent points, or CTPs. Those points are the ones which will build up the topographic profile of the line in its central axis. Another point to measure is the so-called reading points or measurement stations, in which during the survey work, a stake with information such as coordinate, chainage, and number of the measuring station will be installed. The reason for being these stations is to provide a visual guide of where the line is located. The separation of these measurement points will depend on the regulations of each country, but it is advisable to take them into account in order to have, let's say, like a signaling of the alignment of the line in place. Previously, we have talked about the calibration of the equipment. Now, we will talk about the importance of the topic of the tolerances. Tolerances refer basically to the permissible error in the measurement, both horizontally and vertically, in elevation as well, since there will be always errors in the measurements, both as human and measurements in the equipment. As human errors refer to the chainman, who maybe is located 1 or 2 centimeters from the exact point, or the fact that the prism tries to keep it as vertical as possible, but there was always this kind of errors, and that error, both in elevation and astronomical course, is accumulating in such a way that it can lead us to another completely different place from the one that we want to reach physically. The acceptable tolerances can be 5 centimeters for each kilometer as horizontal tolerance and 10 centimeters per kilometer as vertical tolerance. If I'm located on a PI and I'm measuring and I'm accumulated both elevation and heading error, at the distance of the next PI, maybe 1,000 meters away, might not really represent much physical difference. But if the next PI I have, it is maybe 10 or 20 kilometers away, it will happen that when it reaches the next PI, instead of reaching the physical point, it reaches a point perhaps 2,000 meters or more meters out of the target. This is the reason why you must work with properly calibrated equipment and maintain a precision control in the measurements equipment and keep them within the acceptable tolerances. On the other hand, the topographic survey is not limited to the profile of the center line of the axis. There's another very important element to take into account, especially for the cable ground clearances. Side profiles are of vital importance, and these represent the variation of the ground elevation across the width of the right-of-way of the line. A wire will always swing and can approach very dangerously to the side profiles, and this is the reason that it is necessary and mandatory the surveying of these side profiles toward both sides of the line and the full width of the right-of-way, including, and this is the reason for the importance of taking into account the recommendations of the topographer. There are side profiles that might be even out of the right-of-way, but because of its proximity and height, it is worth investing a little more of cost, time and water to survey them and avoid future accidents. Now, the alignment of a transmission line is defined by its PIs, each one of them with its respective coordinate between PIs and PI will be formed a tangent in such a way that a line is defined by several tangents. Each PI is signaled by a large concrete monument embedded in the ground on which the data such as PI number, coordinates, course will be painted. The PI zone should also be marked more clearly with brightly colored stones and flags or stakes painted with certain color codes to identify them. Installing a PI point is not only a task of dig and backfill. No, it's not like that. It is a high precision technique before digging. So the process in order to install the PI is as follows. Number one, the stake of the location of the PI is kept, and you have to wait for the chief topographer to arrive to the PI site. Number two, the topographer positions the total stations on top of the PI by placing the equipment plumb down pointing towards the stake. Step number three, proceed to remove the stake and excavate to embed the PI monument, leaving a small portion from the ground, forming a kind of a monument. These dimensions of these monuments can also be regulated in some countries. So in those where they are not, I really recommend to generate one specification for this one. Step number four. The monument is aligned so that its center coincides with the plumb or the side of the total station. As a step number five, once aligned, it is backfilled and manually compacted, not with machines, completely manual. Step number six, a verification is carried out once again and its final adjustments if necessary. Step number 7. Write on the face of the PI monument the location of the data mentioned above, or whether the regulations request for certain information. And why all this technique for the installation of a simple piece of cement? If due care is not taken in the installation of this PI, the following PI might be completely out of course. This is the importance of the tolerances. In the areas of intersections with particular crossings such as railways, roads, rivers, pipelines, etc., it is advisable to install stakes before and after, just at the foot of the crossings. These stakes will indicate the destination of the road or railroad, the pipeline or on both sides, the coordinates, and the administrative agency to contact for the processing of the permits. Finally, the transmission lines do not always run along easy accessible roads or communications infrastructures, but they're located in areas of very difficult access, requiring a system of permanent access roads, so that the surveying crews at the moment of performing the topographic survey within its scope of work should include the signaling of the access roads for the transmission line alignment. As a final point to the survey with a total station comes the topic of how to use the information for the design process. Before starting the survey work, each client, company, or transmission line designer must establish a list of numerical codes for each type of point. In this way, as soon as the data of the total station is downloaded, a list of every point within its coordinates, descriptions, but more important, a code for that type of SP in particular will be available. These codes can be to differentiate a river, a public road, a rural road, a fence, a construction, a distribution or transmission line, a telegraph line, etc. This system for identification by codes are of vital help to the transmission line designer, especially if working with software like PLSCAD. So it is recommended, in addition of developing these system codes, develop a spreadsheet to deliver data in a clear way, easy access, and in addition to be delivered for the data for the engineer and the total station AutoCAD files, which will be used for the development of the number one document which we will be developing, which is the alignment drawings. As can be seen, the topographic survey of a line with manual methods such as a total station is not an easy task. It is a high precision work on a large scale and can sometimes even be dangerous, because who knows the amount of obstacles or risk along the line, and if someone asks us to be informed in advance and accurately the amount of obstacles, dangers, setbacks which will be found, the right answer is that we will know it until we're walking the line. Everything I say before walking the line is just an estimate which can change from one moment to another. In some countries, and thanks to the development of the LiDAR technology and mapping via aerial photography and satellites, it has been possible to survey the trajectory of both new or existing lines with a great precision, including vegetation of the alignment. And like everything in life, it has certain limitations, but for practical purposes, it is very helpful, and the survey is much faster and safer. So in the next video we'll talk a little bit about this exciting topic. In those countries where topography is used by LiDAR, this technology is not justified for small projects for cost reasons. It is more profitable to do it by hand with total stations for small line segments for small modifications. As mentioned above, each country will have its own regulations, but there might be other countries that do not yet have specifications or are in developments, and the information described here might be useful either for establishing the regulation or improve it. And before we leave, I like to reiterate my recognition and respect to our surveying colleagues, not only of transmission lines but in general, since they are literally those in the far front line. Remember that my courses for designing transmission lines are available in my website. So I dismiss this video with a couple videos on YouTube that I like to share with you, which sometimes they remind me my former times in construction and come to my mind again and again, and also throughout my personal life, since they have raised me in the most difficult moments. So I hope you enjoy them. They have as well subtitles in English. Thank you very much for your kind visit. Don't forget to subscribe to this channel and leave me your comments. So on the next video, Transmission Lines Engineering TV, training to power the world.